Today we are going to learn how to solve a quadratic using another method called completing the square. And so the first few problems that you're going to do tonight will just be asking what number do you have to add to make it a perfect square trinomial. And this is a big concept for actually completing the square. That's what we're doing, is we are completing a square. We're making a perfect square trinomial. And so the way we're going to end up doing that is we're going to look at this term right here. And what we'd end up doing is, if this were a perfect square, this term right here would be double when we go ahead and check those outside-inside terms. So when we multiply the first term of one of the binomials by the second term, let me give you an example here. If I had a perfect square trinomial of, let's say, x plus 3 and x plus 3, you see, if I multiply the x and the 3, and then multiply this 3 and the x, you get the same exact number. So that's why I said this term here is doubled. See, if you take half of this term, see here we have 6x. And then let's go ahead and just rewrite what else is there. We've got the first terms, x and x make x squared, and this 3 and this 3 make 9. So when we have a perfect square trinomial, the middle term is we have the same numbers multiplied to make that. And once you find out what that number is, like in this case it's 3, that helps you figure out what your last term is. So let's go ahead and take half of this term. So that's the first thing we're going to end up doing. So you're going to take this 4 and you're going to take half of it. And so when we take half of it, we have 2. Well, like over here, if we took half of this, we'd end up with 3. And 3 was the number that we got when we went ahead and multiplied 3 by x. So all we have to do from here is take that 3 and square it. And that gives us 9. And that gave me this number right here. And so that's what I'm going to do here. Once I take half of this number, this 1/2 of 4 is 2, I'm going to take this 2 and I'm going to square that number. And I end up with 4. And that's my answer. So 4 is the number I'm going to put there. Over here, same sort of thing. You just look at this number right here, and I need to take half of it. And it doesn't matter whether it's negative or positive. You can write down negative 16 times by a half, because when you go ahead and take half of that, it makes negative 8. But then I'm going to take that negative 8, and I'm going to square it. I'm going to multiply it by itself, and it makes 64. And that's the number that goes in the missing spot. And so now what we have is a perfect square trinomial. If we factored this, you see we'd end up with an x minus 8 and an x minus 8, because minus 8 times minus 8 makes 64. X times x makes x squared. The outside terms make a negative 8x. Inside make a negative 8x. Those add to make negative 16x. So it works. Over here, this one's a little tougher. What makes it tougher is that we have an odd number. So odd numbers are always more difficult. When that middle number's odd, it's going to be a tough completing the square problem. So what we're going to end up doing first is taking half of this term. So half of 7 is a fraction. It's a mixed number. It's 7 halves. But what you do is, all we're going to do is we take that 7 halves and we're going to square it. Now when we square it, we're going to end up with another fraction, 49 fourths. Don't worry about trying to do the division. Just leave it like that, 49 fourths. That's why they even have a bigger box here, because they knew you'd write it as a fraction. 49 fourths is the number that you'd put there. So we're not going to have to deal with this odd number. You'll notice that each of the problems that you deal with tonight all have an even number as the middle term. And actually, the way they're set up in the first 3 problems is actually a nice way, because this is what we have to have first. So the first thing you're going to end up doing is moving your constant over to the other side, but it's already there. So what we want to do here when we solve is we want to first complete this square. We want to make this a perfect square. So we want it as a trinomial. And so what we're going to do is we're going to take this 6 and we're going to take half of it. When I take half of it, I get 3, but then I'm going to take that 3 and I'm going to square it and I get 9. And that's what I'm going to end up adding to both sides. So notice that I'm going to add 9 to both sides. And when you add a number to one side, you got to do the same thing to the other side to keep the equation in balance. And so now it's in balance. So what I'm going to do from this point is I'm going to take this trinomial and I'm going to factor it. Well, this will factor to 2 binomials that are exactly the same. It's going to be x plus 3 quantity squared. It's going to be 2x plus 3's. And that's what you get from this trinomial right here. And so from there, I go ahead and add these two numbers right here. Negative 8 plus 9 gives me 1. And so we're almost done. All we have to do now is eliminate this squared symbol, and then I'll be able to solve for x. So we're going to do the same thing we did yesterday. When we solve square root problems, we're going to take the square root. See, if we take the square root, that'll cancel out the squared symbol, just like it did when we took the square root of x squared. It made it just x. And so what we've got left is an x plus 3, and this all equals plus or minus 1. And then from there, and the reason it's plus or minus 1 again, because there's two numbers that make 1, either 1 and 1 or negative 1 and negative 1. Well, from here we have one more step. What we're going to end up having to do is subtract the 3. And when we do that, we've got two problems to set up. So we have the positive 1 take away 3, which is negative 2. We also have the negative 1 take away 3, which gives me negative 4. So I've got those two as my answers. So negative 4 comma negative 2. Those are the two x-intercepts. And you see, this way is a way that you can solve any type of quadratic. And even if they have irrational roots, we'll be able to solve it. And we're going to see that later on. So again, the first thing you do is you take this 4, and we're going to take half of this number. And so when I take half of it, I get 2. But I'm going to take that 2, and I'm going to square it. And that gives me 4. And that's the number that I get to add to both sides. That completes the square. That's where they come up with this word, completing the square, because I just completed a square, a trinomial square right here. This ends up factoring, and it factors as a binomial. And the factored form is x plus 2, but there's another x plus 2, and they're exactly the same, so I wrote x plus 2 quantity squared. And this all equals 4. Actually, I'm sorry, it equals 16 because I need to add those two numbers together. So let me fix that right now. So I'm adding 12 and 6, or 12 and 4 to make that 16. And so from this point, all we have to do is take the square root of both sides, and that will cancel out this squared symbol, leaving me just with this x plus 2. And it equals plus or minus 4. Well, from that point, there's just one more step. All you have to do is subtract that 2 from both sides. So I'm going to take away 2, and we're left with our two problems. We have 4 take away 2 and negative 4 take away 2. So you end up with a 2 and a negative 6. And there it is, negative 6 comma 2. So those are the two x-intercepts. So let's take a look at the next one here. Taking a look at the next one, we end up having to take half this b term again. So negative 2 times by a half gives me negative 1. But then I've got to take that negative 1 and I square that number. And that's how I end up with positive 1. So that's the number I get to add to both sides. And then from here, I have a trinomial square. So I'm going to end up factoring this. And when I factor it, it just factors as x minus 1 quantity squared. And so from there, again, negative 1 times negative 1 makes the 1. Negative 1 plus negative 1 makes the negative 2. And this all equals 16. 16 from the 5 plus the 1. Well, from that point, you take the square root of both sides. And so we end up with this x minus 1. And this all equals plus or minus 4. So from there, all we have is just one step, and that is to move this 1 over to the other side. So when you add 1 to both sides, we end up having to do 4 plus 1, which gives me 5. And then I also have a negative 4 plus 1, which gives me negative 3. So I get my two answers of negative 3 and 5. Well, just a couple more problems here, a few more. Here we end up having to move some terms over to the other side. So here I first need to subtract that 13. You always have to isolate the constant first, move that over because you want to complete the square. So now what we have is this, x squared minus an 8x. This all equals negative 13. Now I left a little bit of room here because I'm going to end up completing the square at this stage. So I'm going to take that negative 8 and I'm going to multiply it by a half, and then I'm going to end up with negative 4, and I'm going to square that number. And that gives me 16 when I square negative 4. So that's what I get to add to both sides, the 16 and the 16 right here. And so when I do that, this is what I end up coming up with. I end up with this x squared minus an 8x. And, oops, actually I'm going to go ahead and factor that as I go. So let's just fix that real quick. So So let's go ahead and factor that. It's going to factor down to whatever our b term is, x minus 4 quantity squared. And this all equals, and here we end up with a 3. Well, when we go ahead and try to take the square root, we can't take the square root of this 3. And what we'll end up having here is a irrational number. You see, you take the square root of both sides, and what we have is just x minus 4 equals plus or minus the square root of 3. Well, from that point, all you have to do is subtract, or actually do an opposite operation. Add this 4 to both sides. And so the way you're going to write the answer is just 4 plus or minus the square root of 3. And that's it. That's as far as I'm going to have you take the problem. We're not going to take the square root of the numbers that aren't perfect squares. So we're going to end up seeing that with this next one as well. So let's take a look at it. So the first step is to move that 34 over. So I subtract that from both sides. So I've got this x squared plus 6x equals negative 34. So from this point, we're taking that b term and we're taking half of it. So half of the 6 gives me 3. And then I take that 3 and I square it, and I get 9. And that's the number that we're going to end up adding to both sides. And so when I add that 9, I end up with a perfect square trinomial right here, which ends up giving me an x plus 3 quantity squared. X plus 3 quantity squared. How do I get that x plus 3? How did I know it was x plus 3? Well, I know it's a perfect square. I know 9 times 9 makes 3. X times x makes x. That's how I picked those numbers. And I know they add to make 6x because I just checked them right here. Well, when I do this subtraction, I end up with a negative number. I end up with a negative 25. And there's a problem right there. Because when we go ahead and take the square root of both sides, I can't take the square root of a negative right here. And because of that, that means we don't have an x-intercept. So there's no x-intercepts here. There's no solution. Well, one more problem. This one does have a solution, so let's take a look at it. I'm going to add this 35 to both sides. And when I do that, I end up with an x squared minus 2x. And I'm going to leave a little bit of room for that equal sign and putting a number in there. And I'm going to put the number by taking half that b term. Half the b term gives me negative 1. Negative 1 squared gives me a 1, and that's the number I'm adding to both sides. And so once I do that, I can go ahead and rewrite this as a binomial being squared, x minus 1 quantity squared, and all equals 36. So when I go ahead and take the square root of both sides, I end up canceling out that squared symbol. And so I'm left with this x minus 1 equals plus or minus 6. So all we have to do from there is just move that 1 over to the other side by adding it to both sides. And so I get my two answers by just adding 6 and 1, makes 7. And then I also have negative 6 plus positive 1, that equals negative 5. So there it is. 7 and negative 5 are the two x-intercepts. So those are the types of problems you'll see on tonight's homework. Good luck.